Water past paper booklet. So the first question asks you to plot a graph and draw a suitable line. Okay, everyone should be able to do that, and the suitable line was the line of best fit. Remember, no shading, straight through. The second part of this question then, describe the solubility of potassium chloride changes with temperature. As temperature increases, solubility in water also increases at an increasing rate. 1 mark, you've got to make sure you write at an increasing rate. A saturated solution of 80 grams is equal to 20. Describe what you would see and explain when this happened. The solubility will decrease as temperature decreases. You would see excess potassium chloride forming at the bottom. Remember, solubility means how much will dissolve in water. That means that you won't have as much dissolving, so you'll have like a powder forming at the bottom. So the next question then, give the letter X, Y or Z whose solubility changes most with temperature. That's Y, because you can see a really large increase by here. Give one similarity and difference between the solubilities of X and Z as the temperature increases. Same solubility at 84, so they cross over at 84. X is more soluble as temperature increases, or it's more soluble in general. The solubility of another substance Y was recorded at different temperatures, so you've got to plot it and plot a suitable line. Remember again, it says draw a suitable line, so 2 marks for plotting, 1 mark for drawing a suitable line. Using the data to calculate the mass of crystals formed, if a saturated solution of W containing 100 grams of water, so check that by there, this is 100 grams of water, was cooled from 80 to 40, so find what it is at 80, draw a line across, extrapolate the data, find what it is at 40, draw a line up and extrapolate the data, and take them away from each other. Right, final solubility question. The graph shows different solubilities of sodium sulfate and sodium hydronate in water at different temperatures. Give the maximum solubility of sodium sulfate, so where can you get the maximum? That's 50, you can see that's where it peaks. Compare the change in solubilities of sodium sulfate and sodium hydronate at different temperatures above 45, so above 45. Okay, sodium sulfate decreases in solubility, sodium hydroarsenate increases. Calculate the difference between the solubilities of them both at 10, so find them both at 10, you can see I've done dots, and take them away from each other. It's a difference, nice 2 marks, 1 mark for finding them, another mark for taking it away. Then this is a question you practiced before, it just says to find the MR, draw the table, element, how many, mass, total, you should have got 168. Calculate percentage by mass of sodium in sodium hydroarsenate. Again, how much sodium divided by the total, and I rounded it. Well, I had 1 decimal place, I rounded it to full numbers. So next question then is a fluoride question. Give the range of DMS scores in the countries between 1980 and 1990. So the highest was 6.9, the lowest was 2, so take them away from each other. Which country had the largest decrease in mean DMFT between 1980 and 1990 and 2000 and 2009? It is Italy. Okay, you might have had to do a little bit of working out because Finland and Italy are quite similar. Suggest a possible reason why Switzerland has a low mean DMFT before 2000. Fluorine is in toothpaste, they might have been using it in mouthwash. What is the percentage decrease in mean DMFT in France between 1980 and 1990 and 2009? So take them away from each other, divide by the largest number, 74%. Again, I've rounded it. State how the graph can be used to support the argument for fluorination of drinking water in Europe. Mean number of DMFTs decreased. Okay, so the number of people needing fill-ins decreased. Give one ethical reason and one medical reason. Opponents of fluoride use this to support their views. It's against human rights. Okay, so it's mass medication, and it can be bad for your bones, cause osteoporosis, bone cancer in young teens. Next question then was the 6 marker. Okay, that is a little bit complicated. Describe what the graph tells us. Use the information and your knowledge of fluorination to explain why some people support fluorination of water supplies but others oppose it. In 2008, fluorinated water had led to less DMFT than other 2 areas. In 2010, both fluorinated and newly fluorinated areas had seen a decrease in DMFT. Newly fluoridated has seen the largest decrease. Okay, and you can see I've started to work it out here. So it did take a little bit of thinking, but it is a nice 6 marker once you get going. This is the main reason people support it. Fluoride encourages remineralization of your teeth. However, as you can see from the graph, unfluorinated has seen a decrease in DMFT. It has just taken longer. This is why people oppose it, as mouthwash and toothpaste also contain fluorine. Excess fluorine has also been linked to cancer in young boys, brittle bones, and can cause tooth decay. Next question then, very similar again. Doing the experiment again. State which water sample contains only temporary hardness. Explain your answer. C, because after boiling it's soft. If it had permanent hard water, it'd still need a lot of soap after. Give one similarity between the composition of temporary and permanent hard water. They both contain calcium ions. Discuss the benefits and drawbacks of living in a hard water area. Benefits: good for heart, tastes nicer. Drawbacks: causes lime scale in pipes. Scum can form. It means that you put plumber costs. So 13, describe the process of water treatment of our water supply. Sedimentation slows water down, large pieces drop to the bottom, large insoluble pieces drop to the bottom. Water carries on. Filtration, small insoluble pieces are filtered out using a net. Chlorination kills bacteria. What is meant by desalination? Desalination is the process of removing saline, so salt from water. Explain why this is carried out or how it's carried out. Distillation, it's large-scale distillation. Same kind of question then, but just a little bit different. Name each stage. So sedimentation, large insoluble pieces are removed. Stage 2, small insoluble pieces, which are filtration. Stage 3, then chlorination. Domestic water supplies in Wales are obtained from several different sources. Underline the source that is not used to supply water in our homes. The sea. We don't need the sea in Wales because we've got large sources of lakes and rivers. Water from different parts of the UK contains different amounts of dissolved calcium and magnesium ions. Calcium and magnesium ions cause hard water. State 2 problems caused by hard water. Lime scale can build up. Expensive plumber costs. State 1 way in which hard water benefits your health. Improves your heart function. So this question was working out the solubility of ammonium chloride, so how soluble, how quickly it dissolves. They gave you the method by here. What practical problem is the student likely to come across in finding the first 2 results? Suggest how this problem might be overcome. So the first 2 are using quite low temperatures, so 4 degrees, 10 degrees. Then obviously you can use water baths, these ones. So low temperatures, you could use ice, so put them in ice instead. Then it asks you to plot the results and draw a suitable line. Again, 3 marks, so 2 for plotting, 1 for a suitable line. The student is given a boiling tube containing 5 grams of ammonium chloride in 10 grams of water. He stirs the ammonium chloride in the water and heats it to a temperature of 45 degrees. State whether the ammonium chloride dissolves, give a reason for your answer. All dissolve as is the correct temperature for solubility, so it will all be soluble, so it will all dissolve. So next question then. Bottle contains 2 liquids. One has a boiling point of 57, the other one has a boiling point of 95. Describe the process of distillation and explain why it can be used to separate both liquids. Both liquids have different boiling points. Heat the liquid until 57. Liquid E will start to evaporate and turn into a gas. It will then pass through the condenser, cool water, and be collected as liquid. Liquid F would remain in the other bottle beaker. Okay, so that's distillation. This is quite a tough question here then. 1 molecule of liquid E contains 2 oxygen atoms. The percentage by mass of oxygen in liquid E is 43%. Use the following equation to calculate the relative molecular mass of liquid E. So mass of oxygen, so there's 2 oxygens, so times that by 2, so that's going to be 32, because you've got 2 oxygens. You don't know the MR, so I put that as X in my calculations, times by 100, and then you know that it equals 43%. So it's just a little bit of a rearranging of the equation to get to the X, and then you should have got 74.1, okay? Remember, the hardest bit there is most people would have put 16 as their mass of oxygen, but it says it's 2 oxygen. So, last question then is removing hardness from water. It says to talk about boiling and adding washing soda. Boiling water removes the calcium or magnesium ions from temporary hard water. The boiling forms a CaCO3, so calcium carbonate precipitate, which you can filter out. Okay, so that only works with temporary hard water. Washing soda is a cheap alternative which removes hardness from both temporary and permanent water. Washing soda is formed from NaCO3, so sodium carbonate. That's added, so can be dissolved in the water. And what happens is the calcium or the magnesium bond to the carbonate ions, and then you can precipitate that out, and you leave sodium in the water, which is alright because it's quite good for your heart.